In this video, you're going to do some additional examples where you're given the coordinates of 2 points that lie on a line, and you'll be asked to produce the equation of that line as well as a graph of that line.
So, as we did in the first part of this, we're going to, try to ultimately come up with the equation of the line. We're going to draw the graph too, but there's really no major difficulty with that because in all these cases, you're going to be given you're going to be given two pairs of ordered pairs. So, so you'll have your coordinates. You could draw the line pretty easily. So this one here, it passes through 6, -1, and 6, 5. So, at first glance, and maybe some of you catch it on that this is a special line as well, much like one of the ones we did in part one. Um, if you don't, the graph would definitely demonstrate that for you. Notice that if I plot these 2 points and draw the line between them, it's a vertical line. Now, if you remember, vertical lines, much like horizontal lines, have very similar setups. Basically, if I know I have a vertical line, I can just skip to the chase and say, okay, well this line has all x coordinates of 6 and the y coordinate could be anything it wants to be. Therefore, I could just describe it as x equals 6. But what if you didn't notice that along the way? Maybe you didn't come up to that conclusion or you didn't draw the graph. What would kind of point out to you that you do have a vertical line here? Well, if I start calculating the slope for this and do -1 -5 over 6 minus 6, I end up with -6 over 0. I cannot divide by 0. Dividing by 0 is an indeterminate form. Um, and basically that tells me for our cases here that the slope is undefined. And by definition, what we've discussed before is that an undefined slope is the slope of a vertical line. So I know at this point it is a vertical line, and once I know it's a vertical line, either by graphing, noticing that they have the same x coordinate, or getting to a point where I calculate the slope as being undefined, either one of those three are acceptable ways of coming to that conclusion, then I know I have to write it in the correct format. And basically, since x is always going to be 6 and y doesn't matter, y doesn't show up in the equation, all I would do is say again is that x equals 6. So, so even if you don't notice it from looking at the points and you didn't draw a graph of it, the slope calculation will eventually reach a point where it will point out to you that you have a situation where you have a vertical line because the slope is undefined. Let's try this one now. So for this one here, again, the graph is not a big deal because if I plot -3, 6, and 0, 1, there would be my line. Um, Now, as always, when I start problems like this, I'm going to start off by finding the slope. So I'm going to take my two y coordinates and subtract them, take my two x coordinates and subtract them in the same order in which I chose my y coordinates. So I end up getting 5 over -3, which is a -5/3. Now, you can then put this in slope-intercept form if you so desire, using one of these points. There's another method I'm going to demonstrate that some of you may have seen before as well in previous algebra courses. But if you're vigilant enough, 0, 1 is a y-intercept. I can see that graphically because it's on the y-axis. But anytime I have an x-coordinate of 0, that tells me that it's a y-intercept, which means that 1 is the value for b. So I have the two parts I need to write this in slope-intercept form. And slope-intercept form is written y equals mx plus b. So all I have to do is replace the m and the b with their parts. And I end up with the equation y equals -5/3 x plus 1. On to the next example. So see if you come up with the equation of this line here. Well, as with previous examples, as far as the drawing goes, the drawing can sometimes lead me on some information or to come up with information that's helpful later. But here's the 2 points. I'm graphing them. I'm plotting them, and I'm going to draw the line that connects them, and that should be what the line looks like. To get the equation of that line, I'm going to calculate the slope, which is going to be negative 1 minus 2 over negative 2 minus 1, which gives me negative 3 over negative 3, which is just 1. And so when I look at y equals x plus mx plus b, I can rewrite that as 1x plus b, or just say xb. The coefficient's 1, then I just don't usually write the 1. Now, another method that we could use, you notice I'm starting with slope-intercept. I didn't put this into point slope first, which is, something I could definitely do as well. Once I know what the slope is, what I can do is choose one of the points and then plug that into the slope-intercept form, where I'm going to use the x-coordinate as x and the y-coordinate as y. So this tells me that 2 equals 1 plus b, which means that when I subtract 1 from both sides, b equals 1. And so the y-intercept is at 0, 1, and I can see that from the graph right here. I mean, the line is passing through 0, 1, so this all seems reasonable and I'm on the right track. So taking these two pieces of information together, y equals x plus 1 would be the equation of this particular line. On to the last example of part 2. So this one here has some decimals as coordinates, but the procedure is not going to be much different than it was before. The only thing that's going to be different in all the other cases, I was able to graph the line immediately. Here I could take some guesses, but it would be difficult for me to graph this precisely without guessing, because I don't have this scaled going by tenths. I have this scaled going by ones. I could guess where, like, 0.6 and 0.2, 0.3 and 0.1 would be, but I'm looking to not have to guess. And then maybe if I come up with some good coordinates that the line also passes through, then I'll have my equation. I could also graph the line a lot more easily. So take a moment and see what you can do to find the equation of the line, and then we'll go through this. Okay, so as we have done previously, I'm going to start by calculating the slope. So I have m equals 1.3 minus negative 8.6 over negative 1.1 minus 2.2. And again, that's just me taking the y coordinates and the x coordinates in the same order when I look at their ordered pairs. And when I calculate that through, I get 9.9 over negative 3.3, which simplifies to be negative 3. So it's a pretty nice, number for a slope. And I'm going to use the second method again like I had before. I'm going to just go right to y equals mx plus b, because that's usually the desired format that your textbook wants you to produce. I know what m is. I have two instances where I know what x and y are. So all I have to do is pick one of them. And for the purpose of this problem, I put the negative 3 in for m, and I picked my coordinate that I'm going to use to help me with this is the second set here, which means I'm going to replace y with negative 8.6 and x with a positive 2.2, and I work these out. So to get b alone, I'm going to add 6.6 to both sides, and that gives me a minus 2, which means that I know m is negative 3, I know that b is negative 2, and so with the information I have, the equation of the line is y equals negative 3x minus 2. Now, with this equation, this is a lot easier to graph because I have nice integers for my y-intercept. I also have, a pretty well-defined slope where I'm not counting by any decimals either. So, using the fact that b is negative 2, I would plot my first point there. The slope can either be interpreted as first of all, I would interpret it as negative 3 over 1 or 3 over negative 1, which means I either have a rise of negative 3 and a run of 3, which means down 3, right 3, or I have a rise of 3 and a run of negative 1. I think I said negative 3 on the other ones for the bottom, but it's 1, which means that, in that case, I'm going to have a rise of positive 3 and a run going left 1. So that information from the slope would give me these additional points, and of course that would allow me to draw the line that passes through all of them. And that brings me to almost the end, because now if I want to see reasonably where negative 1.1 and 1.3 are, and 2.2, negative 8.6, those would be good, somewhat decent locations. But since it's not, they don't go along with the scaling I have here, it would have been more problematic to try to graph them, beforehand. So, but that now brings me to the end of this problem. So,
That's the end of this video. As always, if you have any further questions, please make sure to get in touch with me. Until next time, have a good day.